Have you been wondering how to build a successful strategy with open source for your company? Or why would you invest in open source projects when you can use the code for free? Are you an open source maintainer on the edge of burnout? Or a newcomer who's too intimidated to take the first steps and get involved? Maybe you're not a code developer and you think that there's no place for you in the open source ecosystem. You're not alone. My name is Ildiko, and this is the My Open Source Experience podcast, where my guests and I share our open source journeys with all the successes, the struggles, and joyful moments. Find the answers to your questions and dilemmas, and more importantly, join us and be part of the community. Hello, everyone, and welcome on the My Open Source Experience podcast. Today, I have Brad Chamberlain with me, and I'm super excited because we will talk about the Chapel project. And it's not just a quote-unquote regular open source project. It is, in fact, an open source programming language in the supercomputing space, which I am personally always super excited about. And when it comes to projects around programming languages, I'm a little less familiar with those. And we will talk about this project from the creation towards its journey to the High Performance Software Foundation, or if you're familiar with the space, HPSF, which the project joined recently. But before we go all into this, Brad, can you please introduce yourself a little bit to the audience? What is your background in tech and what do you do currently?
First, thanks very much for having me. My name is Brad Chamberlain. I'm a distinguished technologist at Hewlett-Packard Enterprise. And I'm a sort of a combination computer science researcher and computer programmer. I got my background, like a lot of kids in the 80s, programming VIC-20s and Commodore 64s in my parents' basement. These were very exciting to me, kind of electronic toy that you could make do whatever you wanted. And so I taught myself some programming there. In college, I continued that and majored in computer science. And then it was really in graduate school at the University of Washington that I got my current focus on supercomputing, so large-scale computers for doing massive computations, and specifically doing programming languages designed to make supercomputing easier than it is today.
So it sounds like that from the early days of teaching yourself how to code, you really got a passion for programming languages, like how to tell the computer what to do.
Yeah, for sure. I mean, I think the thing that was so mind-blowing about those early computers in the 80s was, again, the sort of flexibility that, up until then you could buy electronic games that would do one thing or, toys that would do certain things. But the notion that you could sit down at a computer and use one of these programming languages to have it do something that you wanted it to do, as you were thinking of it. I think one of the first things I did was with one of my friends in the neighborhood. We programmed it to play Mary Had a Little Lamb and to render the notes on the screen at the same time. And I'm sure we did it in a terrible way that I would kind of, wince at. But the fact that we could just sit down and let's see if we can do this and could make it do it was very kind of mind-blowing to me at that age. And then through college, I got exposed to different languages, and yeah, that sort of led to me to where I am today. To talk a little bit about my career path, so when I graduated from graduate school, I spent a year at a startup that was very educational, but also challenging. I then took a job at Cray about a year later, and that's where I was a software productivity lead. And then in 2019, Cray was acquired by Hewlett-Packard Enterprise, and so now I'm a Hewlett-Packard Enterprise employee. But yeah, the first job I had at Cray was that Cray had just started this government program. They were one of 5 companies to participate in this program sponsored by DARPA that was called the High Productivity Computing Systems Program. And the whole notion of this program was that as a nation and worldwide in the HPC community, we're very good at building larger and larger and faster computers, but we're not very good at making ones that are easier to use. And so the goal of this program was to focus not just on performance and scaling up performance, which is where supercomputing and HPC typically focus, but instead to look at, well, how can we make these systems easier to program? And so when I was hired as a software productivity lead, basically my job was to figure out, like, well, in software, what kinds of things could we do to make supercomputing users more productive? And so again, that was my initial role when I joined Cray.
So it's kind of helping people to be able to use the software easier and better. So it's not about making the software, let's say, more productive, but the people who are trying to use and interact with it, or kind of a little bit of both.
I would say a little bit of both. So I think, I'm realizing I use the acronym HPC, which for me stands for high performance computing. So again, supercomputers, large computers that can do lots of operations in parallel and solve some of the world's most challenging problems. And I would say our community tends to be very focused on, again, making bigger and bigger systems and faster systems. But often the software side of it, the user side of it, is kind of left in the dust. Sometimes I equate it to being a race car driver, where, if you're a race car driver, not that I know much about it, my assumption is that it's all about how fast can you go? Can you win the race? And probably not as much about the driver's comfort and, experience in the car and things like that. And I think the HPC field is a little bit like that as well. We're very focused on solving these problems, but sometimes the practicalities of using the system, programming it, using the tools on it are left in the dust. And so as a company, we were challenged, and as the software productivity lead, I was challenged with what kinds of things could we do in software, either making existing software easier to use or producing new software that would make these HPC systems easier to use, more productive, more resilient to failures. Basically just anything that would kind of bother users, slow them down. How can we iron out those bumps, essentially?
So you kind of came a little bit of full circle from your childhood experience of that programming with your friend, and maybe the program that you wrote wasn't the most efficient, the nicest way to code that particular functionality, all the way towards trying to figure out how to make supercomputers a nicer experience to use. That's pretty cool.
It's a crazy difference in scale. The VIC-20 I mentioned had, if I remember correctly, 3.5 kilobytes of memory, which a photograph today that you take on your smartphone would probably be bigger than that, right? And these supercomputers are just massive. Even in my career, when I was a graduate student, when I finished my PhD, I was really proud because I had done some runs that used 256 processors or 256 compute nodes, which at that time was a pretty big number, I think, particularly for a student like myself. And now I've had members of my team run on over 8,000 nodes and over 1 million processor cores. And those are just numbers that, I couldn't have conceived of even as a graduate student, let alone as a teenager in my parents' basement. So yeah, the scales of these systems are mind-blowing and seemingly getting bigger and faster all the time.
I mean, those numbers, to me, who's not working in the supercomputing space, they are still pretty big.
They're the kinds of numbers where, sometimes people will give you these numbers we sorted 256 terabytes of data, and you're like, I can't even conceive of what that means exactly, right? It's just hard for us to get a grasp on, I think, as mere humans.
That is true. However, once you run a podcast and you keep running out of external hard drives because 2 terabytes don't seem to be enough for anything anymore, then you start to grasp it. Although after that experience, I really don't understand how all the world's data fit into any device, or the collection of devices that we have on this planet, because that's just insane.
Right.
Insanely enormous amount of data. Learning coding in the basement and, parents' basement and garages, that kind of sounds like the grassroots open source movement. So I'm curious if you remember when you first heard about free and open source software. Maybe it wasn't even called open source just yet.
So definitely it was after my teen years. I think the open source movements were definitely starting around that time, but I was unaware of them until later. I remember when I was in college, so GNU was something that we knew about, and that's, of course, part of the early open source movement. And I remember it in particular because a couple of friends and I, late night in the lab, would just get into these loops where we'd say, what does GNU stand for? And someone would say, GNU is not Unix. And they would say, but what does GNU stand for? GNU is not Unix. And we'd just do that like we were dumb college kids, basically, for way too long. But I don't know that I necessarily knew heavily what GNU implied at that time. Like, I think you're in college, you're given software, you don't really know whether the college is paying for it or not. I remember in graduate school becoming aware of Linux and that movement and being sort of intrigued by it, and also being a little bit puzzled from the perspective of, well, how do they make a living if they're not charging for this, right? So I definitely have some memories around, that's like when I think of myself as first hearing about open source and kind of as an alternative to Windows, which was pretty dominant at the time, and Mac to an extent as well. I feel like a light bulb moment for me, even though it was kind of later. I mean, I definitely knew more about open source by this point, but I don't know if you remember or ever saw the movie Antitrust with Tim Robbins, but it was a movie that came out in 2001 or so, where basically like the idealistic young open source programmer is being courted by the big closed source, for-profit software company. And, it's basically a big sort of espionage, like, tense movie kind of thing. And I remember that being sort of like, oh, okay, like this is a real thing. Like somehow it turned it from something that I was obviously using day to day into something that made it much more concrete for me somehow by telling this completely fictitious story. So that was kind of a turning point for me. But again, I certainly knew about open source before then, but somehow that was like an anchor when I was, reflecting on my history with open source for this interview.
That's interesting. I need to look up that movie. I probably saw it, but as someone being from Hungary, we like, if you see something on TV, for example, then it's most probably dubbed to Hungarian. So in terms of the movie titles, I never really know, because creative people like to do creative things, which means that sometimes the movie's title in Hungarian has nothing to do with the original English title or whatever language the movie was. They tried to make sure that the titles relate to the people in Hungary as opposed to where the movie is originating from. Right. And sometimes that lands in mysterious places, which is a head scratcher once you learn the original title of the movie. Like, where did our title come from?
Yeah, it would be fun to watch it again and see if it aged well.
So in terms of learning about open source, all the big revelations, was it still a bit more about the fact that there are people who are writing software that is available for free of charge? Or did you also, in the early days, like how much did you realize of the community that was behind that free and open source software?
I would say in those days, really not so much. I was a user of the technologies, but I don't know that I was aware of the open source movement and ecosystem much. I think I heard about it a little bit from some of my office mates who were operating systems researchers, and so I think they were more aware of some of that than I was. But I would say that my own experience with becoming more aware of it, more involved with it, started with one of my roommates when I was in grad school. At some point kind of pulled me aside and said, Brad, I'm a taxpayer and you're an academic, and I imagine that some of my taxes are paying for your research, and yet your project isn't open source. Like, shouldn't it be? I mean, don't we deserve to get access to the software you're writing on our tax dollars or whatever? And I think he had a really good point. But I remember being very stressed by this because, when you're a graduate student, there's a point at which you're just trying to do everything you need to do to get out, and it is a big challenge. And the thought of also open sourcing it and dealing with supporting open source users or contributions or thing like that was pretty overwhelming to me. But at the same time, I didn't really have a counter argument for him. So I don't remember exactly when it happened, but the language I was working on in graduate school, which was called ZPL, at some point we did start releasing it open source. To be clear, we had been releasing it for free before that, but in a binary only release, which of course can have portability problems and doesn't give you any confidence in what's behind the binary. And at some point we did start releasing the source for it. It was around the time, it was probably, I would guess, just after I graduated. So 2001, 2002, I would guess. But that was sort of one of my first personal interactions with thinking about doing open source myself. Even for a lot of the early part of my career, I was still fairly unaware of the size and scope and activity in the open source community. And I feel like for me, it was really when GitHub came out and became prominent that somehow that provided more of a sense of community, and we're all in this together. We're working on a similar platform. Not to say that every project is hosted by GitHub, but somehow that platform made it feel more like a thing that I became aware of and where we were part of and things like that in a big way.
So it seems like that open source was a bit maybe easier to discover and access once a platform like GitHub became a big and more widely known thing.
That's the way I think about it. And it's not to say that open source wasn't present or available before it. It certainly was. But somehow the community aspect of getting external contributors, having sort of an integrated place where your source is hosted and where your releases can be done and where users can file issues, just kind of bringing that all together in, what was a pretty nice platform compared to things we had been using before. I think that really was, for me, a bit of a light bulb moment in terms of, not just being sort of individual isolated people, but communities. And again, to be clear, I recognize in hindsight that there were big communities at that time. They just weren't ones that I was personally affiliated with. Open source has kind of been in my career, I guess you could say, a means to an end rather than a driving philosophy of the work. So it's been something I have used both as a user and as a developer, but was not something that I was deeply invested in from like a community hobbyist awareness kind of perspective.
I mean, I do love how you mentioned that conversation with your roommate, for example, like that sort of social aspect a little bit of open source in terms of those tax dollars and that kind of common good kind of thing. It's also interesting how you started the involvement in the open source ecosystem by open sourcing something rather than stumbling on a community, which I think might be a bit easier today, and the regular experience that someone just stumbles on a project, either from personal experience or their company told them so, and then there's the community and they need to figure out how to be part of that community, how to start participating, and all those kind of things, the contributions and the things that you mentioned. But it sounds like that you're taking more of the creator role in this ecosystem. We're here to talk about the Chapel project, which is one of the programming languages. Before we talk about the life cycle of the project, can you just briefly describe Chapel, what the project is, and what it brings to the ecosystem today?
The motivation for Chapel and for ZPL, the language I worked on in grad school before it, was that programming, well, I should say, doing parallel programming at all is hard. And for those who don't know what parallel programming or parallel computing is, it's basically the notion of using multiple processors or multiple computers cooperatively to solve a problem faster than you could otherwise. And so a simple analogy would be, if I have some problem that's going to take me 100 hours to solve, well, gosh, if I had 99 friends help me with it, maybe we could solve it in 1 hour because we could split up the work. Now, the complication, of course, is that just like if you had 99 friends helping you, you'd have to do a certain amount of coordination between those friends to make sure everyone was doing unique work and the results were coming together in the right way and people weren't stepping on each other's toes. The same thing is true in parallel computing. And so it sort of has all of the challenges you would have in traditional desktop sequential or serial computing. But on top of that, there's the problems of coordinating all of these parallel workers. If you're using large-scale systems like supercomputers or the cloud, you may have data in different memories and you need to somehow get the data back and forth between the memories. So there's sort of a lot of details to deal with. And the theme of both Chapel and ZPL before it were to be languages where those details were handled much more automatically for you by the language, by the compiler, by the runtime, and less sort of you having to deal with everything yourself manually. And so at a really high level, you could think of the goal of Chapel as being to have a language that is sort of as approachable and easy to read or write as something like Python might be. Not to say Python's the perfect language or anything, but it's obviously very popular, and I think it's sort of readability and writability is a big part of that. But where Python is a language that hasn't really generally resulted in great performance or parallelism or scalability, which is the notion of running on these very large-scale systems. Our goal is to get the same kind of performance and scalability that HPC programmers would expect from the conventional technologies that they use to program them today. And so the big difference between the two is, in the conventional technologies, often you're being very explicit about, now I want to copy this data from my memory over to your memory. Now I want to have you start working on this. And all of that's very explicit. And in a language like Chapel, a lot of that is abstracted away by the language or by abstractions in the libraries to prevent you from having to deal with it in quite such an explicit manner all of the time.
Let's take a look at how Chapel was created, because open source kind of plays a big role in the fact that Chapel even exists in a way. So I'm excited to dive into that. And you kind of already described a little bit where the need to create Chapel came from, in terms of having a language that was really suitable for supercomputers and large-scale systems, while also being maybe a bit more user-friendly than some of the other languages at the time. It might still have been a bit of a challenge to, let's say, convince a company that, hey, we actually really do need a new programming language. Because I think you were at Calais when the idea came up, right?
Yeah, that's right. The setting was that I was a reasonably new hire at Cray, and I was put in charge of this question of how do we improve software productivity for supercomputers. And again, given my background, nobody would have been surprised. I said, oh, well, obviously, among other things, we should develop a new programming language. And at that time, I reported to the chief scientist at Cray, who was also the principal investigator for the DARPA program I mentioned earlier. And his immediate reaction was, no, I don't think we'll do that. I don't think we can do that. And I mean, he was polite about it, but his rationale was, he said, I think if we as a single company develop a programming language, it'll never be successful. And so why waste our time? And at that time, again, I was new to the job, still pretty new out of grad school. And who am I to argue with the chief scientist? So I was like, oh, okay, I'll go come up with some other ideas. But then as I stewed on it over the coming weeks and months, I realized that I could come up with languages that had obviously become quite popular, that had started at a single vendor. So I think C is a great example of that. More contemporary for that time, Java had just been an example of that. And one of the great things about our chief scientist, who is a mentor of mine, was, he was the kind of person you could go back and say, I've been thinking about this, and I want to kind of challenge you on it, right? I'm not sure I'm convinced. And so he said, okay, well, tell me about it. And I sort of gave him my brief argument. He said, yeah, okay, well, let's think about this. Let's take the languages that we care about as a community, sort of the HPC community, and let's think a little bit about where they came from and what that tells us. And so we put together this little bit of a sort of a map of kind of where languages came from. And I actually have the slides here. Is it okay if I share them with you? And
yes, please.
So these are the slides we developed at the time. We basically divided the world up into these 6 categories. And, I look at it today and I feel like, this isn't perfect. Maybe I'd do it differently if I did it today. But at the time, the 6 categories we came up with were lone hardware vendors, so kind of who we considered ourselves to be at the time. Hardware vendor consortium, so cases where a bunch of different vendors got together and worked on a language. Independent software vendors, you can think of this as like people who just develop software. Academics, government labs, and then open source fanatics. And I don't remember how we came up with these 6 categories, but then we started thinking about, okay, well, what are the languages we care about and where do they fit into things? We started out with these languages, for those of you who can see the screen, that are in green. And I use the term language loosely here. Some of these aren't technically languages, they're libraries or pragma-based markups, but I'm just going to use language because it's a way of expressing things to a computer, and I think of that as a form of language. And so in lone hardware vendors, we had C, which I mentioned earlier, Java, which I mentioned earlier. C++, we kind of put on the line between lone hardware vendors and open source fanatics. SHMEM, which is a technology used in HPC that was developed at Cray, actually. Then under hardware vendor consortiums, we had Fortran, high-performance Fortran, which had kind of been a big deal the decade previously. OpenMP, which is still a very important technology today. And then down in government labs, we had MPI and UPC, which at the time were two of the dominant ways of programming distributed systems, and MPI to this day still is. And so from there, we sort of took a step back and said, well, where did some of these things come from? Because in many cases, these technologies were evolutions of other things. And so we kind of came up with predecessors to those current languages. And so, for example, we started with kind of modern Fortran at the time, Fortran 90, Fortran 95. But we stepped back and said, even though that is sort of a vendor consortium effort, if we go back to Fortran 66, that was from a lone hardware vendor as well. And so we looked at the history of these things and saw that not only did some of them obviously stem from single vendors, but in fact that sometimes if you went back, you would see predecessors to things that had become consortium efforts coming from single vendors as well. And then the third step we took was to take a bunch of other technologies, some of which were important to HPC, others of which maybe a little bit less so, but sort of captured other elements that we wanted and looked at where they fell. And by virtue of going through this exercise, at the end of it, he was like, okay, yeah, I'm convinced. We can do a language. And I remember one of the other things we talked about in that conversation was, but the key is that we don't just hang on to it forever, but that we also think that it's important to have it become a consortium effort over time, whether through open source or a vendor consortium or something like that. The idea being that, we think that it's healthier for language, better for the community, and that users will come to it more if it becomes more of a cooperative effort over time. And that's a little bit of foreshadowing there. But yeah, this is the exercise that led us to going from, no, we're not going to do a language, to like, okay, yeah, let's do a language. And that's what led to Chapel.
So there were kind of maybe two debates really close to each other. And one is whether or not Clay should start developing a new programming language. And then the other one is how to make it successful and widely adopted. So make it really worthwhile to implement it. You decided that it is worth to start your own language, and then you also decided to then later on open it up and make sure that you have a community around it. Like in the open source fanatics part of your diagram, there was Python and Ruby, which are currently pretty popular, and communities might have something to do with that. This is how open source and this community aspect started to play a role in Chapel's existence and history. Once the decision was made that let's do the programming language, was that hard to start up that project, or was it fairly straightforward within Clay from that point that, I don't know, you will work on it or a team will work on it, or what the next steps were to get the project started?
Yeah, so I think there are kind of two elements to that. One is sort of the mechanics of starting the project, and I'll start there. And the other would be sort of what led us to make it an open source project. I would say for starting the project, were there challenges? I mean, yes and no. Like on one hand, it was a really beautiful, idealistic time because somebody tells you like, yeah, you can make a language, which is, what I was passionate about coming out of grad school. It's what I cared about and thought was really important and still do to this day. And so you're sort of given this opportunity and to an extent this blank slate. And much to the credit of the project, it was a very good thing that it wasn't just me in charge of it. In fact, I was sort of in charge of the implementation, but one of my other mentors, David Callahan, was in charge of the project as a whole. And that was really great because if I had been in charge of it, what we would have created would have been sort of the next generation of the language I had done in grad school, which was a really interesting academic project, and I would say a successful academic project at what it set out to do. But again, in hindsight, had really zero chance of being adopted in terms of some of its limitations and constraints. And to David's credit, and to my terror at the time, he basically said, no, like this language has to be, like it has to be big, it has to do everything. Like you can't hit a point where you're like, well, that was good while it lasted, but now that I need to do X, I need to go back to conventional HPC technologies. And I say that this terrified me because my role at that time was I was in charge of implementing the language. And so he would say, like, and accurately, in retrospect, we need everything that you would want in a traditional language, a desktop language, a mainstream language for productivity, and then everything that we need for parallelism and scalability, the things that make us unique. And so the reason that was terrifying was, if you look at most popular languages, they are very, very large. Either the language is large or their library is large or both. And the thought of reproducing all of that while also trying to do these things that were very unique from a research perspective in terms of parallelism and scalability, as the person in charge of the implementation, it was really daunting. Like, well, if we did something simpler, I'd be much more likely to be successful. So that's sort of the mix of the excitement of a blank slate. What are we going to build? Those days and hours sitting around in rooms debating, should we have this feature or that feature? How will we express this? That was a really fun, fertile time for doing a lot of brainstorming. And then there was the reality of getting it all implemented and getting it working. And that's been my career more or less ever since, to a large extent.
In my experience, creating something and making it open source, that's the process of that is not that complicated. Like, you slap a license on it, you put the source code out to somewhere in the open, and then people stumble on it or you advertise it. That's part of the first steps, and the rest is history, kind of thing. So as you mentioned that you put out the project and you still did a little bit of internal development on the project, which in my experience also happens kind of often, that especially when a group of people starts an open source project who don't have a lot of experience in the open source space, then it's not that self-explanatory how to do the design and development and everything in the public and an open space. It sounds like that for the Chapel project, you had the right ideas. And then as you were progressing with the project after literally creating it, you still needed to learn about those steps in terms of getting more comfortable with that public and open space and start to do the design and development there. Do you remember how long it took for you to step out of this? Maybe we should not develop this internally and then share what we did sort of a little bit after the fact, but making the whole entire process open source. Like when did you get to that point in the the Chapel project creation phase?
So you're definitely right that, particularly given the time we're talking about, right? So think of 2003 as when we were having these meetings, trying to figure out what we were building and how. And some of the coding started probably in mid to late 2003, I would guess. I was checking our repository. The first commit to our repository was January 2004. But that first commit had a lot of code in it. So obviously we had been developing before that. And I think it's exactly what you were saying, that it's not as though we were invested in keeping it secret and keeping it to ourselves or anything. It was more just sort of, at that time, there were large communities working on open source. There were not sort of publicly easily accessible ones like GitHub or GitLab today, where you could just jump on and sort of spin up your own repository and suddenly you've got it, right? So at that time, I think we didn't know a lot about hosting an open source repository, creating an open source community, things like that. And so we leaned on my connections still back to the University of Washington. And I think we actually applied for a small grant there or something like that to help with this. But essentially, they provided hosting services for us for those first few years and helped us with things like revision control and access, and kind of took care of the sysadmin part of it. At that time, Cray didn't really have the resources ourselves, or sort of the legacy of open source software that we had by the end of the project and that HPE has today, to host an open source project ourselves. So partnering with University of Washington on it made sense in terms of letting them play to their strengths and we could focus on the language and the compiler. But over time, I think as the notion of how open source software was developed evolved in the community, we evolved to meet that. And so sometimes this was things related to tools. Like when we first started at the University of Washington, we were using CVS, which is an older Unix-based revision control system. And then at some point, I remember the University of Washington admins coming to us and saying, there's this great new thing called Subversion. You should be using it instead. And we're like, oh, okay. And so we started using that. And then at some point, it became, I think, known that, if you're an open source project for real in this day and age, you should be on SourceForge. At least that's what, leadership in our company thought. And so it was in 2009 that we made the jump from being hosted at the University of Washington over to SourceForge. And again, that sort of started to bring us into more of an ecosystem developed for open source projects. I remember it had mailing lists. We could have kind of a very perfunctory web page through them. And again, sort of it took care of the administrative aspects of running an open source repository and doing releases and things. And then later, as GitHub rose to prominence, we both switched from Subversion to Git as our revision control software, and also switched to GitHub, which, even at the time we switched to it, we weren't particularly early adopters, but, it was sort of, I would say, heads and shoulders above SourceForge in terms of capabilities and modern interface and things like that. So yeah, there was very much this evolution in our project of, I think we thought of ourselves as open source from the start because we knew we were going to release as open source, but sort of the specifics of how we developed the source and how we fostered a community and fostered collaborations and accepted source definitely went through many evolutions over the course of the project, and probably will evolve further still going into the future, I imagine.
It sounds like that you were asked to deliver a unicorn of programming languages a little bit that just does it all. Usually in my experience, and I haven't been developing software for a little while now, but I did at one point in my career, or a few points rather. And you usually don't start out with this thing has to be able to do everything that a thing like this might, could do. So that was usually not the starting point. And I think there were people sort of advocating to do the opposite, just to really figure out what you need to focus on. And then as it grows, you can always refactor and rethink things, but usually try not to boil the ocean, so to say, from the beginning. So did it make that planning phase excruciatingly long? How was that experience?
I mean, this is exactly what I was intimidated by, right? Was we were sort of promising to do it all and had good reason to want to do it all, ultimately. But as you say, you can't do everything on day one. And the analogy I always have in my mind is growing crystals or growing rock candy, if you've ever done that in a solution. Initially, the crystal is very small and there aren't very many facets on it. So there aren't that many places you can contribute and make it better. But as time goes on, it gets bigger and there are more places you can have people contribute, right? So in this analogy, initially it's we don't have a compiler, we don't have a runtime, we need to build those things, but they're not going to be able to do very much yet. But, over the course of the project, it's now, of course, much bigger. There are many more facets where people can contribute. I guess we haven't really talked about time frame, right? So this was basically 23 years ago that this conversation with the chief scientist occurred, more or less to this week, plus or minus a week. And it took us, when I look back at the timeline preparing for this interview, it took us a long time to get things going, as you're saying. And we didn't try to do everything from day one, but we knew that ultimately that's what we wanted to do. And so our focus was typically on the things that made us most unique. Because, if the first thing we did was create an amazing traditional language, everyone would say well, we've got a bunch of good languages, why do we need this? And so we really focused on the parallelism, the distributed data structures, the things that would make it really different, and that we thought would make it really productive. But some of the downsides of that, of course, are we put off features that were key. I remember one that we intentionally put off for a very long time was error handling exceptions. And it's programs have errors. They need to deal with those errors. And we're we agree, we're not disagreeing, but we have to pick our battles. And today, that's not our battle. I'm happy to say today we do have an exception handling story, but it did take us a long time to get there. And one of the other things that took a very long time was getting good performance. So we had a point where we had the parallel features, we had the distributed features, but the performance was terrible. In fact, for years it was terrible. And this is really a non-starter in HPC. I mean, the whole point of using these systems is to get good performance and scalability. And we believed we had created a language that would allow us to achieve that, But again, you can't do everything on day one. And so on day one or day 10, day 100, year 5, I don't know, we didn't have performance. In fact, for a very, very long time. And so yeah, it's required a lot of patience from our fans and from our community to get to this point. And I think the good thing is when people try it out today, everything is not perfect. I don't mean to imply it is, but we're in great shape compared to where we have been for the vast majority of the project's history. And that's been really exciting to see come about.
And to clarify, 23 years ago this week means November in 2002.
That's right.
I'm curious a little bit in terms of the history of Chapel. From the early days to today, there's a lot of work and effort going into not just creating a project as open source code base, but also as an open source community. Do you remember how you set up governance for the project at the beginning, for example, and how that evolved?
Yeah, I can talk about that. I'm smiling because we didn't really think about governance for the project until really the past year or so in any significant way. And I realized that to a lot of open source projects, that would be ludicrous. But let me explain a bit more about why. So, initially, as we've talked about, this project came about through this DARPA program that our company was participating in, and it was part of our response to that program. And so there was no doubt in our minds that even though we were creating something that was going to be open source in terms of its releases initially and eventually its development, that it was our project. We're going to do with it what we want and need to do, right? We're in charge. And that attitude has prevailed through most of the project. And I've said it in kind of a jerky way, right? It's not like we were jerks about it. And we would certainly take input, particularly from users, into account. We got a lot of great feedback from users, places we had designed something not as well as we could have or overlooked something. We'd hear that and respond to it. But there was never any doubt in our minds that this is our project and we're going to do with it what we need to. I mentioned that sort of that started to change about a year ago. And, it's probably been, I would say, maybe a little bit more gradual than that. But the thing I'm referring to there is, so a year ago, we decided that we were going to apply to this new foundation. I think you mentioned it before, the High Performance Software Foundation, or HPSF. This is a new foundation that was started up under the Linux Foundation, which, of course, we were familiar with. And HPSF is all about creating open source software for HPC, for high performance computing, that is has the goals of improving user productivity and growing the community. Things that, as you could tell from our earlier conversation, are very much kind of part and parcel of why we were doing Chapel as well. The other thing I'll refer back to is in that initial conversation with Burton Smith, our chief scientist that I mentioned at the time, we noted that while a lot of successful languages started with a single vendor, the most successful ones ultimately became community efforts or multi-vendor efforts or multiple organization efforts. And so I remember him saying in that conversation, so we need to make sure that we do this at some point, we don't just hang on to it forever. And this is a problem we had wrestled with over time with the community. So I guess you could say this is us wrestling with governance, but we were sort of how do we do that? How do we establish a Chapel Foundation if we wanted to do that? How do we move the governance and ownership of the project outside of Cray at the time, outside of HPE more recently? And we wrestled with it, and we ultimately would say, well, gosh, that's a lot of work. And we'd ask the users, how important is this to you? And they would say, not that important right now. And so we just sort of never got around to it. It's kind of like hosting your own open source project. It sort of felt like a lot of work. And then once HPSF came on the scene, which was probably about a year and a half ago now, I think they sort of officially launched, if I remember correctly. We were oh, well, these are our kindred spirits. Their mission matches our mission. This is probably exactly what we've been looking for as far as not doing it all ourselves and going it alone, but becoming part of this bigger community. And so we applied, I think it was October 1st of last year or something like that. And one of the requirements in applying was you had to point to a bunch of things, one of which was your governance document. And we were well, we don't really have a governance document, but here's loosely how we're governed. Which was basically we make the choices, we listen to user input, we put things up on GitHub issues so users can comment on them and weigh in, and then we're going to decide what we're going to decide. And to be very fair to HPSF, they said, well, you really need a governance document, but it's fine that you don't actually have an open governance model yet. Like, that's something we want you to work towards, and that's something we wanted to work towards as well. But mostly you need to have some sort of governance document saying, like, laying this all out, like what you've just explained to us about, practically speaking, how does it work? And so it was only as part of finalizing that application that we put together that we created that. And in fact, I think if I remember correctly, that was the beginning of this calendar year, because it took a while for our application to get processed and get to the top of their stack. And that was one of the first and main pieces of feedback we got. That's kind of how we got to our modern thinking about governance. And as a result of the application process, we have now formed what we call our technical steering committee, which is like a formal voting governing body. It is still largely HPE employees by virtue of the fact that sort of the traditional thing, as I understand it in Linux Foundation projects, is to have everyone with commit privileges have the opportunity to be on that governing body on day one. And when I say commit privileges, I really mean merge privileges in GitHub lingo. So the only people who have merge privileges today are HPE employees from kind of a security safety perspective. So we review all pull requests. And therefore, the initial governing body today is still dominantly HPE. That said, one of the first tasks we are wrestling with as a governing body is, how do we add new people to this? Because we have users and collaborators that we think would be great on this body. But what is the process that they should use to apply? And we want to make sure to set that up fairly so that we're not just sort of letting our friends and family in, but then like we're exclusionary to other people, right? So we want to sort of establish what the process will be and then start putting some of our long-term users and collaborators through it.
And then when you're talking about security, you mean that you want to make sure that people who work for the company that hosts the testing infrastructure on premises review the code that comes in to make sure that there's no malicious software being merged into the code base that then runs on your machines in your network.
Yeah, exactly. You sort of have to picture the worst case scenario, right? So a bad actor who, is working for a competitor HPE or just would benefit from seeing HPE fall, or, the same with our sibling projects in the DOE labs. Somebody who could check in code that would be run automatically without a human looking at it. You can obviously have screening software help with that. I'm skeptical that a screening software setup could find every bad actor who is very sneaky about things, right? How do you sort of build trust to know like whose code you're willing to run without somebody reviewing it, or how do you build up the trust of people who you trust to review it before running it? Those are sort of the hard questions here, I think. And again, we were, I would say, relieved to find that it wasn't within the HPSF. It wasn't just us. It's sort of by nature of supercomputers and how rare they are and who uses them and who develops them is sort of a common concern across the community, I would say.
I do know communities where there are companies who are offering labs and they do testing in their own lab behind their firewalls. So there is probably an opportunity to collaborate within the broader open source ecosystem and figure out how those companies do these type of things, because it seems like that on a big general scale it is doable, but it always boils down to the details. Before we depart, Brad, can you please tell us something about yourself that has nothing to do with supercomputing, programming languages, or even open source, some kind of a hobby or a fun fact?
Yeah, I'll tell you two of my favorite hobbies. So one of them is music. I feel very, very passionate about music and always have my whole life. And one of the things I guess it kind of relates to my job. And one of the things I like about my job is that often I can listen to music while working. And that, like, even if I have to do kind of the most boring task, listening to music makes it worthwhile. So yeah, music is a huge passion of mine. These days, mostly listening. I used to play trombone as well.
Did you ever play in a band?
Oh yeah, I mostly played in bands. I was not so much of a solo trombone player, more of an ensemble player, typically. And I played through graduate school. It was a big source of stress relief for me in grad school to be able to go play the trombone once a week. And the other one that I has been kind of more of a relatively more recent passion is I've gotten very much into board games, which, many people in this community probably know have kind of had a golden age in the last 10 years or so. And so I really love board games, particularly sort of medium to heavy Euro style board games for those that means anything to. They really they exercise my brain in ways that I really like. And that's been a fun way to spend time.
Do you play board games with family, or you have like a friend group who you can play board games with, or do you play those online? Because you can now play these kind of games online too, a lot of them at least.
It's mostly been with my family, though my kids are growing up now, and so they don't have as much time for board games anymore, which has been kind of sad. But yeah, primarily with my family, occasionally with friends or with extended family. Yeah, I might need to find a friend group as my kids continue to get older, or I might drive my wife crazy at some point. I'm not sure. We'll see. We mostly also play cooperative games. We found that we really like working together against the game rather than working against each other for the most part. So most of the games we've spent most of our time with, I would say, are cooperative in nature, which for me was kind of a revelation that a board game could be cooperative, not anything like what I had growing up.
Do you have a favorite of those?
Yeah, my very favorite is Gloomhaven, which is, for those who don't know, it's a board game that each game sort of has a lot of very interesting kind of choices and puzzling and tactics involved with it, how you're going to sort of get through that scenario. But then there's also this long narrative arc and progression of characters and retirement of characters and picking up of new characters. And I like the combination of it being a cooperative game that has a strong story to it that sort of progresses over time, but where the game itself is very kind of crunchy and analytic in nature and without a ton of randomness. There's some, but I tend to like games that don't depend heavily on randomness, and there's sort of just the right amount in Gloomhaven.
Awesome. I'll check that one out. I was looking into, I think it's called Board Game Arena. That's an online platform where you can play these, similar games and board games and different kinds of games. I don't know if this one is there or will ever be, or if there are similar, more cooperative games on that platform. I wasn't that deep into it. I'll check if there might be an online version of it or something similar online. Sounds kind of fun.
I think people do play it online. I don't know how good or bad the experience is offhand, but I think that's an option. And Pandemic is sort of one of the first big cooperative games, at least that I was aware of. And that one I'm almost certain you can play online. So that would be another one to check out.
Awesome. Thank you for sharing.
Thanks so much for having me.
And with that, that's all, folks. That was our episode for today. What did resonate with you the most? What new ideas, strategy, or useful tips did you hear today? Or you have a comment or follow-up question to ask? Comment on the episode below, or start a conversation on your favorite social media platform. Don't forget to like, subscribe, and share the podcast so others can discover it too. And stay tuned because the next episode is just around the corner.